Hello friends, welcome back to my channel Fast Physics. In today's session, we will learn about motion in a circle. So let's start. Circular motion. First, we will see which type of motion is called circular motion. Let this is a particle which moves in a this circle like this. Then the motion of this object is called circular motion. That means we can define the circular motion like that. If any object move in circular path, then its motion is called circular motion. Let's see how many types of circular motion. There are two types of circular motion. First one is uniform circular motion and second one is non-uniform circular motion. So what is uniform circular motion? If object moves with equal angle in equal time interval, then it's called uniform circular motion, or in other words it can also defined as if any object which moving in circular paths has uniform speed, then it is called uniform, then its motion is called uniform circular motion. And let what is non-uniform circular motion? And this object's motion is called non-uniform circular motion. That if object's speed is non-uniform when it is moving in circular path, then its motion is called non-uniform circular motion. Let's see some definitions when object moves in a circular path. First one is time period. Time period is what? Time required to complete one cycle in a circular path is called time period. It is denoted by T and its unit is second. And let's see next definition of frequency. Frequency nu. What is frequency? Total number of cycles per unit time is called its frequency. If any objects moving in a circular path, then total number of cycles completed by the object in unit time is called its frequency, and generally it is denoted by nu. Somewhere it is denoted by small f or small n, and its unit is cycle per second or hertz, and hertz is denoted by hz. Let's see the relation between time period and frequency. So we can find the relation between time and frequency like this. In t second is equal to 1 cycle. That means in t second objects completed 1 cycle. Then number of cycles in 1 second will be equal to 1 by t cycle, and hence 1 by hence nu is equal to 1 by t. Nu is equal to 1 by t because number of cycles in 1 second is its frequency. Therefore this will be equal to nu, and which will be equal to 1 by t. And in this way this shows the relation between frequency and time period, and it can be written as nu t is equal to 1. Let's see about angular displacement del theta. So first we will see angular displacement by figure or diagram. This is a circle and O is its center. Any object is at point P, and suppose the radius of this circle is R, and this object is at point P, and when we apply it a force on this object, then it shifts to another point. Suppose this point is Q, and in this way objects has some linear displacement, and there is some angular displacement also. Here suppose del s is the linear displacement of this object, and del theta is its angular displacement. Then here del theta is called angular displacement, and we can define it as angle in radians through which an object rotates in a circular path in certain time interval is called angular displacement. That means यदि कोई ऑब्जेक्ट जो सर्कुलर पाथ में मूव कर रहा है वो सर्टेन टाइम इंटरवल में जितने एंगल से रोटेट कर जाता है उसे हम उस ऑब्जेक्ट का एंगुलर डिस्प्लेसमेंट कहते हैं, एंड इट इज डिनोटेड बाय डेल थीटा and its unit is radian, and which is written as rad, rad. This angular displacement is vector quantity and it is dimensionless quantity. If angular displacement del theta is vector quantity, then it will have a certain direction, and its direction is known by right hand thumb rule. That means इसकी डायरेक्शन को राइट हैंड थंब रूल की सहायता से हम प्राप्त कर सकते हैं. तो लेट अस सी व्हाट इज राइट हैंड थंब रूल. तो राइट हैंड थंब रूल क्या है? इमेजिन द एक्सिस ऑफ रोटेशन टू बी हेल्ड इन राइट हैंड with the fingers curled around it and thumb out stretched. If the curled fingers give the direction of motion of particle performing circular motion, then the direction of outstretched thumb gives the direction of angular displacement vector. That means यदि हम अपने राइट हैंड को इस प्रकार रखते हैं कि फिंगर्स जो है एक एक्सिस के अराउंड कर्ड हो, मुड़ा हुआ हो, और हमारा जो थंब है वो आउट स्ट्रेच्ड हो, बाहर की ओर स्ट्रेच्ड हो. तो इन दिस कंडीशन यदि हमारी कर्ड फिंगर जो है पार्टिकल्स की उस सर्कुलर पाथ में मोशन की डायरेक्शन को डिनोट करता है, तो थंब जो है एंगुलर डिस्प्लेसमेंट की डायरेक्शन को डिनोट करेगा. तो आइए इसको एक एग्जांपल के थ्रू देख लें कि एंगुलर डिस्प्लेसमेंट की डायरेक्शन किधर होगी. ये है सर्कुलर पाथ है, इस पर कोई ऑब्जेक्ट जो है क्लॉकवाइज डायरेक्शन में रोटेट कर रहा है. अब इस क्लॉकवाइज डायरेक्शन में यदि हम अपने फिंगर को रोटेट करें तो हम इमेजिन कर पा रहे हैं, हम अपने फिंगर को बेंड करें तो हम देख पा रहे हैं कि थंब जो है इस स्क्रीन के परपेंडिकुलर इनवर्ड्स होती है, देन परपेंडिकुलर डाउनवर्ड्स फ्रॉम द प्लेन ऑफ सर्कल. दैट मीन्स एंगुलर डिस्प्लेसमेंट की जो डायरेक्शन है वो क्या होगी? परपेंडिकुलर डाउनवर्ड्स फ्रॉम द प्लेन ऑफ दिस सर्कल. And let us see another figure. In this condition, object is moving in anti-clockwise direction. In this condition, direction of angular displacement vector will be perpendicular upward from the plane of circle. Let us see the relation between these two displacement. This is the angular displacement and this is the linear displacement. Let us see the relation between these two. Here linear displacement is arc PQ and which is equal to del S, and since we know that angle is equal to arc by radius, and here this arc represent the linear displacement and which one is del S, and radius of this circle is del R, then del theta is equal to del S by R. This gives the relation between angular displacement and linear displacement. Let us see now angular velocity. What is angular velocity? Rate of change of the angular position of any rotating object with respect to time is called angular velocity, and it is denoted by omega, and it is a vector quantity. That means किसी ऑब्जेक्ट का जो रोटेट कर रहा हो टाइम के साथ एंगुलर पोजीशन में परिवर्तन की दर को हम एंगुलर वेलोसिटी कहते हैं और इसको हम ओमेगा से डिनोट करते हैं और ये क्या है, वेक्टर क्वांटिटी होती है। इसकी यूनिट होती है रेडियन पर सेकेंड और इसकी डायरेक्शन क्या होगी, चूंकि ये वेक्टर क्वांटिटी है तो इसकी कुछ डायरेक्शन भी होगी। तो यहाँ पर हम देखते हैं कि कोई ऑब्जेक्ट है जो इस एलिप्टिकल पाथ में एंटी क्लॉकवाइज डायरेक्शन में मूव कर रहा है। तो इनकी यदि एंगुलर वेलोसिटी से देखें तो ये जो है आउटवर्ड होगी, आपका आउटवर्ड डायरेक्शन में होगी। और इसको हम इस प्रकार भी कर सकते हैं, एंगुलर वेलोसिटी की जो डायरेक्शन है वह एंगुलर डिस्प्लेसमेंट की डायरेक्शन में होगी। दैट मीन्स एंगुलर वेलोसिटी को भी हम राइट हैंड थंब रूल के माध्यम से इसकी डायरेक्शन पता कर सकते हैं। And angular velocity is equal to angular displacement upon time interval. This is the figure here. Del theta represent the angular displacement. Suppose this angular displacement is obtained in time interval del t, then omega will be del theta by del t, where del theta is angular displacement and del t is time interval. This is the angular velocity. If we want to find instantaneous angular velocity, that means तात्क्षणिक कोणीय वेग, then then तात्क्षणिक कोणीय वेग मतलब angular velocity at certain moment. That means at that point time interval will tends to zero. Hence, by taking limit, we can find instantaneous angular velocity like this. Instantaneous angular velocity omega will be found by taking limit del t tends to 0 del theta by del t, and according to definition of derivatives this will be equal to d theta by dt. Hence omega is equal to d theta by dt represents the instantaneous angular velocity. Omega is equal to 2 pi by t according to this formula. That means in t time interval, where t is the time period, in t time interval, object rotates through total angle 2 pi. Therefore omega is equal to 2 pi by t, and since 1 by t is equal to nu, that means frequency, hence omega is equal to 2 pi nu. This gives the relation between angular velocity and frequency nu. Let us see another relation. Since omega is equal to del theta by del t and v is equal to del s by del t, where v is what? This is the linear velocity, and del theta is equal to del s by del r, which we have already seen. By differentiating this with respect to t, we get del theta by del t is equal to 1 by r into del s by del t. And del theta by del t is what? It is omega, and del s by del t is linear velocity. Therefore, omega is equal to 1 by r into v, and v is equal to r omega. In this condition, we can say that v means linear velocity, and the direction of linear velocity is always perpendicular to radius of this circle, and always perpendicular to direction of angular velocity. Hence, in general form, we can, in vector form, it can be written as v is equal to r cross omega, and in general form, this formula can be written as omega is equal to v perpendicular by r, because v linear velocity is always perpendicular to omega and r. Therefore, we can write it as omega is equal to v perpendicular by r. Let us see about angular acceleration. So what is angular acceleration? Time rate of change of angular velocity is called angular acceleration and it is denoted by alpha and its unit is radian per second square. And according to definition of this angular acceleration, alpha will be equal to del omega by del t. And if we want to find instantaneous angular acceleration, that means तात्क्षणिक कोणीय त्वरण, then by taking a limit of time, as previously we have taken limit, we can find the instantaneous angular acceleration like this. Limit del t tends to 0, del omega by del t, and which is equal to d omega by dt. And since omega is equal to d theta by dt, then instantaneous angular velocity is angular acceleration is equal to d 2 theta upon dt square. And this gives the relation between angular displacement and alpha. Since V perpendicular is equal to r omega, therefore by differentiating it with respect to time, we can find d V perpendicular by dt is equal to r d omega by dt. And this d V perpendicular by dt represents to linear acceleration. And since linear acceleration is there are two types of linear acceleration. One is the radial acceleration and another one is tangential acceleration. So here this dv perpendicular by dt will be equal to tangential acceleration, hence at is equal to r alpha, and this gives the relation between linear acceleration and angular acceleration. At is equal to r alpha. So friends, to prepare this PPT, I have take help of Wikipedia, Internet, NCERT, 11th book and University Physics. तो आज की क्लास में बस इतना ही. यदि आपके पास कोई क्वेरी है, इफ यू हैव एनी डाउट, you can ask in comment box. सो थैंक यू फॉर वाचिंग. यदि आप अभी तक कोई सब्सक्राइब नहीं किए हैं तो आप प्लीज सब्सक्राइब कर लें और लाइक करें और शेयर करना ना भूलें. ओके, थैंक यू अगेन.